In this lecture, we shall try to understand the Stramit, the design capacity tables, and member movement capacities, and how we can, check the Purlin sizing and design calculations as per the UDL. So it is not that we do need to, design each and every time the Purlin sizes. The Stramit do has a like manual where we can simply, scroll down to the span, scroll down to the Purlin size, scroll down to the number of spacings, and it shall simply tell us that what exactly is the design capacity in kilonewton per running meter. So before we jump onto this table, we shall try to study the basics again. So this we have already understood. That is 350 GSM is the the minimum galvanization requirement. The mass and the steel grade. So strength is basically here we can see G450, G500, G550 is available. Thickness is in the range of 1 to 2.4, and for the higher size it is in between 1.9 to 3 mm. And the unit weight is approximately 2.43 kg per running meter for 150 mm C or Z purlin to 15.2 kg per running meter for the heaviest purlin that is available, that is 353 mm. So after that, the design that is done is as per the ES 4600 2005. So whatever capacities that we shall be having in this particular manual, the capacities are automatically calculated from AS 4600 2005. So after that, if we want to study about the design tables, so in the design table here you can see that the web dimension is given, the flank dimension is given, thickness, and XC and XS. So basically, if we want to zoom into XC and SS, so XC is basically the distance to the centroid, and XS is basically distance to the shear center. So shear center is located outside of the member and centroid is located inside of the member. So as per the the manual they have given, so here we can simply find out what exactly is the value of the center and what exactly is the value of the shear center. So after that, if we want to study about the the self weight, so this capacity tables in this manual make no allowance for the self weight. So we have to add the self weight to account for the, we can say, material. So after that, section properties. So design has been carried out as per AS 4600. That is the code for the cold form section designing. And for the suspended load, as I said that many times we do have to hang the service resources like cable trays, or we can say the fire lines. So in that case, the hanging must be done from the web at minimum distance of 25 mm. No connection should be made to the lip of this particular C channel or Z purlin. And also load should not be suspended from the wall girts. Why? Because they are fixed onto the minor axis. So if we fix or we can hang something from the in this particular plane, it may simply sag. After that, local pressure factors are the ones that are very important when we are designing the purlins and girts. Global pressure factors are used in the frame design, and but local pressure factors are used whenever you want to do the purlin design in the steel structures. Bridging, we have already discussed that it provides resistance to the purlin rotation during the installation of roof and wall sheeting. So maximum bridging spacing of 20 into purlin depth, but not greater than 4000 is recommended. And failure to do so can lead to misaligned fastening, causing additional stresses on the fastener and roof sheeting. So that is the simple thumb rule that whatever is the purlin depth, we do have to ensure that that purlin is bridged at the 20 times the purlin depth. So if let us say we do have a 150 mm C purlin, so we do have to ensure that this purlin is we do have to provide the bridging at 3000 mm maximum. Lap, we already discussed that it is usually in the range of 15%. And for unequal spans, we can, opt for the higher lap sizes. Bolting, we already discussed that standard it is M12 grade 4.6 bolt. But in many cases where the load is very high, the span is very high, we do require grade 8.8 bolts. So let us say, for example, for 300 series purlin, we do have to use M16 bolt of grade 8.8 wherever it is indicated in the design tables. So if we want to study about the bolt shear capacity, so 2 into M12 grade 4.6 is having shear capacity of 30.3, and 2 into M12 grade 8.8 is having shear capacity of 62.8. That is almost double here. Same is the case here also. That is for 2 M16 grade 8.8. The bolt shear capacity is 118.7. So after that, we can study about the other criteria also, that is fascia, purlins, cantilevers. So wherever the capacity of the cantilever dependent on the adjacent internal span length. So uh, it has been found that cantilever of up to 20% of adjacent internal span will generally be within the capacity of the section, provided the cantilever ends. So let us say this is the like I section and this is the purlin. So if let us say the span is approximately 6 meters, then it is suggested that this cantilever does not go beyond 1.2 meters, and at this particular point it has to be braced against the rotation and lateral movement. After that, the span is referred to the limit state design capacities and all. Yeah, so if you want to study about the limit state design capacities, so it has been checked as per the yielding, combined bending in, web shear, flexure torsion buckling, distortion buckling, bearing or bolt shear. So for cold form members, there are much more strictness in compared to the checking that we do need to do. That is, we have to ensure that as it does not yield, it does not bend, it does not fail in shear, it does not fail in flexure torsional buckling, it does not fail in distortional buckling, it does not fail in bearing and bolt shear. So after that, these are the full section properties. So let us say if you're talking about the EZ15010, the gross cross section area is 295 mm square, and the Ix and Iy values are 1.03 and 0.25. Similarly, Zx and Zy values are 13.6 and 4.15. Radius of gyration are 59.1 and 28.9. And J and IW value of warping constant are these values. So after that, effective section properties are ZE, YC, IE, and AE. So these are the important properties that we do need to refer. And for example, let us say if we're talking about the EZ 200 2.4. So the ZE value is 51.5 and YC value is 102. And after that, IE value is 5.26 and AE value is 615 mm square. So I and ZE are the effective section modulus at yield stress, and YC is the depth of neutral axis top fiber, and A is effective area at yield stress, that is compression. So similarly, we can jump on to the different type of span configuration. Obviously, it is a single span, that is, it is being supported from at both the ends. Double span, obviously, double unlapped is that we are not providing any kind of lap here, and if it is double lap, then we are providing a lapping at this particular supporting point. And if you're talking about the continuous spans, so this is a continuous lapped span. So here also you can see 1, 2, 3, and 4 number of laps. So this is also clear. And after that, we can jump on to studying the tables. So the table is very clear. These 0, 1, 2, 3 are the number of bridging that we are providing. This dark gray color means that even if we are providing the more number of bridges, there is no change in the section capacities. So let us say if you're talking about the 2500 mm span, for 2 bridges and 3 bridges, 1 bridge and 0 bridges, the capacity is same. But wherever, let us say if you're talking about the 4-meter span, the capacity for 2 bridges and 3 bridges is same, that is 2.03 kilonewton per meter. And here also it is same. But for 0 bridges, the capacity is only 1.13. So similarly, if we study the higher, like uh, C or Z purlins, so here also you can see that for let us say 4.5 meters, for 2 and 3 the capacity is same, that is 3.68. That is even after adding a larger number of bridges as compared to 1, the capacity is same. And here also you will see that some of the numbers, so here also you can see that some of the numbers are written bold and italic. It means that we do have to provide M16 grade 8.8 bolts here. So wherever we are having this bold italic letters, the span is also high, the section is also high, and we do need this as we can say M16 grade 8.8 bolts for the connection. So after that, here also you can see that the capacities here we were dealing with the unlapped span. But after that, we can dealing with the capacity of the lapped span. And here the capacities are outward design capacities. So the thing is that when we are dealing with the wind load cases, we are dealing with the outward design capacity. But when we're dealing with the dead load and live load, we are dealing with the inward design capacity. So inward is for the dead load and live load, and outwards is for the wind load. So that is how you can study the table, and this is available free of cost on the Stramnet website. You can download from them. Now, if we're talking about the like member capacities, so for member capacity, we already discussed that we have to check for the combined bending and shear. So this is the formula which we do need to check. And deflection is the simple, that is it needs to be restricted to span by 150. So let us say we do have a 6000 mm span purlin. So the deflection needs to be restricted to 40 mm. That is 6000 divided by 150. So similarly, if you're talking about the bending and axial load, we have to ensure that interaction ratio is less than 1. And yeah, so here this is a typical bending moment diagram for double span outwards loading case. So here also you can see that the UDL is acting in this particular direction. So here also you can see that the bending moment is going high, and then it is coming down, and then again it is going high, and then it is again getting to 0. So these are like the member moment capacity tables. So this is also they have also given a design example that how we can calculate that. So the thing is simple, that we just have to find out the bending moment, we just have to find out the like the UDL that is coming, and from the table we can simply find out what exactly is the best purlin for our case. Or we can use their software also. So this X Factor design software is available free of cost on the web. So this X Factor is the software, as I said, that is available free of cost on their Stramnet website. So in the next lecture, we shall try to understand that how we can automate our design calculations with the help of this particular software.